So we're back, and let's take a look at the continuation of our slides. There's really not many slides. Actually, I think I only have about 4 or 5 left that we're going to go over today. A couple of them have some detailed animation, and one of the reasons actually we got started just a little late, I was just finishing one of them up that I really hope will help you understand better the inbound and out. Actually, the one I was finishing up was the outbound globalization. It's something that I've been asked for students for many classes to create. I've also created something that we'll use for outbound globalization understanding, kind of a chart, a map, an Excel spreadsheet that I'm debating whether to hand out in Excel or PDF. I might just hand it out in Excel so that you guys can use it, although it's got a couple odd quirks that you have to know how to work with to get it to format right. You can certainly use it for your own customers as a template if you'd like, but the thing that I don't want you to do is study with Excel in the lab or in your own study time leading up to the CCI Voice Lab, because you will need to document this kind of table format. Take your verbose written paragraph format of dial plan that we're going to go over in our tasks and transform it into a table or tabular format. But I don't want you to do that in Excel because you won't have that as a tool in the lab. And if you get used to too much used to studying with that as a kind of a something you can lean back on, you might not be ready to draw it out by hand in the lab. But I'll probably hand out both, and you can use them. So taking a look at some of the issues that we have with international CUCM clusters. We've got different representations of international numbers and different dial rules by country. Okay, so we've got these issues with international CUCM clusters. We've got different representation of international numbers and different dialing rules country by country. So, for example, the US versus most of the EU versus Australia. The PSTN access code for the US is 9. UK is typically 9. Now, of course, this depends on what you want to use, right? I'm just saying most corporations in the US use a 9. Some use an 8. Some use 7. Most corporations or enterprises and PBXs in the UK use 9 as well. Okay, so this is the PSTN trunk code. This is what you would, your users would say, hey, press 9 to get an outside line. And that's where you hear the secondary dial tone, just for the user's comfort, right? You can't change the user's habits. They'll get too mad at us, okay? But for most of the EU, other than the UK, they use 0. Australia uses 0, by and large. Now, those are just things that we can configure. There are other things that the carriers mandate, like national access code, or long distance access code is another way of saying that in the US. We use the access code of 1. That also happens to be our country code, as I mentioned yesterday, and that does afford us a few niceties, like you just saw on localizing, or I should say rather globalizing, a 10-digit number inbound from Amsterdam that begins with 020. We had to drop that preceding 0. If a call came in with a 1, and they don't typically in the US, but if they did, or Canada, if the carrier sent us 11 digits beginning with a 1 instead of 10, we wouldn't have to drop it, because it's not only our access code, but it's also our long distance or national trunk code. So most of the EU uses 0, including the UK, and Australia uses 00XX. Actually, I think a number of South American countries use this as well. 00 being the long distance code, and then XX, fill in the blank with your preferred carrier that you want to have toll or charge you for that long distance or national call. Then international access codes. The US and Canada use 011. The UK and most of EU use 00. Australia uses 0011. By the way, if you put all this together, if Australia has a PBX trunk code, to get a PSTN dial tone of 0, and they're calling the US, so country code 1, then they actually have to dial 00011 to get to the US, right? 0 to get secondary dial tone, 0011 for international access, and then the country code of 1. I just think that's a lot to dial, but that's okay. We have to deal with all these different access codes and rules. We also have complex digit manipulation requirements, such as automated alternate routing between countries, THO, tail and hop off between countries or across country boundaries, extension mobility across boundaries, unified mobility, single number reach, device mobility, SRST, call forward on register across country boundaries. All of those things that I just listed there, or at least most of them, those are the things we're actually going to take a look at in the next module, which is I tagged unlocking the potential of globalized routing. And it's not that I don't want you to see the benefits of it today, but I want you to fully 100%, 1000% understand how to configure it properly without any questions left today. And I think that that will, with the tasks we have, I've created a few complex ones, not too complex. I'll start easy on you, but certainly not too easy either, so that you can fully understand how to do this, how to configure everything. It's important that we do that before we just go seeing all the niceties. The niceties are very easy to configure once we realize how we're going to be doing all of the rest of our digit manipulation. Okay, so let's look at a little bit of preliminary CUCM terminology. Incoming PSTN call, these are calls coming from the PSTN to an internal phone. Outgoing is going from an internal IP phone to the PSTN. Call ingress, here we're talking about the incoming call leg. So calls received by CUCM. By the way, this is received by the server. So this includes IP phones that are placing calls into the CUCM server. In other words, I go off hook on a phone, and when I go off hook, I begin dialing digits. I'm placing an ingress call into CUCM. Then CUCM does its matching and then routes that call out. And so that's the next terminology is call egress. So this is the outgoing call leg, call routed to a destination by Cisco Unified CM. Again, that destination could be an IP phone. So if I'm picking up the phone, 1001, and I'm dialing 2001, that is an example of an ingress and an egress call. The ingress is from 1001, the calling party. The egress is to or toward 2001, the call led party. The call could be coming in from a gateway and going out to an IP phone. It could be coming in from an IP phone, going out to a gateway. Technically, it could be coming in from a gateway and going out to a gateway or trunk. Just depends on how we have call routing set up. Okay, so also number normalization. We mentioned this already, the process of changing numbers to well-defined or normalized format, normalizing our data, essentially to the E164 number with the plus prefix. Number globalization, same basic thing, it's just a subset of normalization. Number localization, the process of changing the number from a normalized or globalized format in this case to the local. And I wrote shortest possible, but I'm not actually sure if I would agree with shortest possible. It's to the user's preference, the user that's being displayed to. Obviously, we're not going to meet everyone's preference, but the large majority of users. And then localized E164 number. So the PSTN number in partial E164 format, such as subscriber, national, or international. This is the format localized to the carrier the way that they want to see the call if they are to route it properly. We'll definitely take a look at that. Okay, a few semi-interchangeable terms. For caller party, or just for caller parties in general, we have calling number. We could also interchange this with ANI or CNG as an abbreviation. Actually, Cisco tends to use the abbreviation CN for calling and CD, so capital C for both, and then lowercase n, CN for calling, and CD, capital C, lowercase d for called or called. I tend to use CNG, as you can see here, just because I think it's a little more descriptive, a little easier to visually recognize and distinguish apart from called. Then we have called number, can be interchanged with DNIS or dialed digits. DD is what you'll see, lowercase dd. We saw that in a trace yesterday. Or, as I mentioned, the abbreviation called, CD. We have redirecting number. This equals RDNIS, or the redirecting DNIS. And there can be multiple redirecting DNISs, as we've talked about in a previous module. We've talked about in a previous module, the ANI never changes. The DNIS can change from hop to hop as we're doing forwarding or redirecting. And the redirecting, there can be many of those redirecting numbers. Okay. Also, RDNIS or redirecting could be loosely associated with forwarding. It doesn't necessarily have to be forwarded. Okay. A call could have been forwarded or transferred. It still somewhat results in a redirecting or RDNIS number. For E164 plan and type, and really actually just type, I don't have anything related to plan in here. Plan would be ISDN or unknown or private if we were connecting to a local private PBX. Maybe we're using ISDN. There's a number of different formats here for plan, but I don't have them listed. The important ones I want you to remember are for type, where local calls equal subscriber. Long distance calls equal the term national, and international, well, equals international. Unknown equals a bunch of question marks. It's just that, it's unknown. We don't know where the call came from. For some reason, the information was not included. And what do we want to do with that? We'll take a look. Okay, so globalization and localization, the call place and type. Now that you hopefully understand a bit more, or possibly even fully understand why we might want to globalize calls, a few questions remain. Where and when, and I've actually already covered these, so I'd like you to answer them. Where and when should you globalize numbers? Anyone want to field a response in the Q&A? When should we globalize numbers?
The ingress.
That's correct. We always globalize numbers at the ingress. Doesn't matter if it's coming from the PSTN or coming from a phone. Where should you localize? This should probably be self-explanatory since we just got done with globalization. We always localize numbers at the egress. What types of numbers should be globalized? Always called numbers and normally calling. I would actually say really always both kinds of calls. What types of numbers should be localized? Any number that has been globalized. Okay, so think globally and act locally. Saying by Patrick Geddes, an activist quite some time ago, I think back in the late 1800s actually, but so here, and I've kind of beat this to death, but I really want it to stick with you, so I'm showing you in a number of different ways, not only saying it, but also hopefully visualizing it. So we've got phones and gateways. We've got our CUCM cluster in our enterprise in the middle. Again, we globalize at the ingress. So when a call comes in from a phone, we globalize the called. We possibly globalize the calling number. If it comes in from a gateway, we're mainly concerned with globalizing the calling number. But we could globalize the called as well. And then we localize at the egress. So if a call is coming in from a phone, leaving to a phone, or coming in from a gateway, leaving to a gateway, this is where we globalize and localize. Okay, I've beat that one to death. Now let's actually take a look at an incoming PSTN call. Okay, we looked at this a little bit in the Prezi slide show that I just put on, but let's take a look at it with animation and also a bit of where to do the configuration. Okay, so an incoming PSTN calls comes in. The carrier is sending the calling party as 206-501-5111. What did we say before? We always globalize the call at the ingress. So the call comes in, and on the gateway page, it's here at the gateway, and it's the gateway CUCM web page, okay, that we're normally doing the globalization. We are going to see a situation where we cannot globalize it at the CUCM gateway web page. We simply don't have enough fields. We'll take a look at where that is and why later. I'm not going to get into that now, but there's a time when we won't be able to globalize it within CUCM gateway web page or trunk web page. If that's the case, we'll do it here at the actual iOS gateway. Okay? But if we can, we do it at the CUCM gateway or trunk web page. So we globalize the calling party. How? We do it by, oh, I'll show the configuration later. I forgot that the way that I arrange this. So we do localization at the call egress, we've already said. So as the call is leaving the CUCM and going to the phone localizes the calling party to 10 digits if it's going to a Seattle phone. However, and we'll talk about this in a little bit, the missed calls will actually always display in the globalized format. Now I should make a disclaimer here. This is only for type 2 phones, okay? Or actually, sorry, type B, I believe is what Cisco calls them. Type B phones, I used to say generation 3 and beyond. So 7961s, 7962s, 7941s, the 9800 series, you know, all of the newer phones from the 7961s and newer. So not 7960s, those were Gen 2, not 7940s, not 7905s or 7912s. But the reason that I've clarified and say type B now, as Cisco says, is there are generation 2 phones. You might even call this a generation 2.5 phone. But like the 7970 color touchscreen, it ends in a 0, the 7970, but it is actually considered a type B phone. Basically what this is any phone that had enough memory, flash banks that could hold the additional firmware or really software that was needed to tell the phone how to get missed calls and placed calls. These are the phones that support the new format of globalized missed calls. If I have an older 7960 or a 7940, or I have a CIPC. In fact, I just did a check, and you know, you might be watching this recorded later, and they've come out with the version by now, maybe a year later or something. But I just did a check with a friend of mine that's on the development team with the CIPC, and they still don't have all the bugs worked out of the version of CIPC, so Cisco IP Communicator, that allows for missed calls showing in the globalized fashion. All phones support localization, but not all phones support globalization. The reason for this is, and I didn't have time to add the arrow on the slide to do this, or the animation, but missed calls on the newer Type B phones, so 7941s, 61s, including the 7970, 71s, etc., and beyond, the older phones, and even these phones before they were updated, used to go back, they used to look to their local NVRAM, or actually I don't even believe it was NVRAM, I believe it was running memory. They used to look to their local running memory to see what were missed calls and placed calls, and it was there on the phone. So the call had been delivered and the information was there local on phone. The newer phones actually do a SCCP skinny call back to CUCM and look in a database there. In fact, all you have to do is hook up Wireshark or used to be Ethereal, and mirror the traffic, span the traffic from your phone switch port to your PC port, and press missed calls or directories and then missed calls, and you'll see a few brief skinny messages go back and forth, and this is carrying the information back to the CUCM database saying, hey, I'd like to look at my missed calls for me, my MAC address, my phone type, and the CUCM then returns those missed calls or received calls or placed calls. And this allows a few different things. It allows us to see the number in a globalized format, and the reason it's in a globalized format is because it hasn't yet been localized. It was localized when the call, okay, in fact, I'll just go back here, when the call was leaving the CUCM to the phone CUCM IP phone web page, that's when the calling party transformation pattern was applied to localize that call. But when I look at missed calls, I'm looking back at the CUCM CDR database where that call has first been globalized by the gateway and is now forever rooted in the CDR as the globalized format. So missed calls on the newer Type B phones will always show the globalized format. All phones support localization, but only the Type B support globalization. It also, that look back to CUCM database, also affords us the ability to have BLF for call history lists. Okay, so busy lamp field, presence, and status for call history lists, but we'll take a look at that in another module. Okay, so likewise, the call, if it's leaving through the phone record of the Austin IP phone, is going to see that in a very different way. Okay, so Seattle only saw 206 and then 10 digits. But maybe our Austin phones want to see 1, the national trunk code, and then the 10 digits, so a total of 11 digits. But the missed call still includes that plus. And maybe the Amsterdam phone wants to see the display, the ringing display, of 00 and then 1, so their international access code. Again, we could just not have a translation rule, and they could just see, or a transformation pattern, and they could just see the globalized format, the +1. It just depends on what the user wants to see, or in the case of the CCI Voice Lab, what the lab proctor task book tells us they want to see for the alerting localized call format. The missed calls will always remain the same. So let's just bring up all the displays here. Again, just a note at the bottom, the callback number is not shown on display. That's only for during ringing, that's only for missed and received calls. And the callback number, or the missed and received calls, allows the user to quickly see, the display allows the user to quickly see, visually identify where the call is coming from in a localized format, but enables globalized numbers to be used for callback. So we really do have the best of both worlds. You might not understand why we want that for the missed calls just yet, but by the end of the module you will. Let's look at the configuration for this. So the globalization occurs at the gateway, and we simply added to 206, we added +1. Okay, so that occurs on the gateway page. This is where we globalized it to +1 206. Then the localization occurred. The configuration is with a calling party transformation pattern based on a calling party transformation pattern CSS on the phone, pointing to the calling party transformation pattern inside of a partition that's in that phone's CSS, the phone's calling party transformation CSS. And that is \++, because we have to escape the plus, \++1 dot, and then the bang, and they're all urgent priority. And at the end of yesterday, we talked about why they're all urgent priority, even though they've got an exclamation, which could result in interdigit timeout. It does not ever result in interdigit timeout because of the way that the calls are being sent to that calling party transformation pattern, and that is, I don't know, does anyone happen to remember from yesterday? Good, someone remembers. That is n block versus overlap sending, or overlap dialing. So overlap sending is one digit at a time. When calls are sent between entities within CUCM, so for instance, the calling party is kind of looped out through the phone web page record, through the calling party transformation CSS, finds a pattern based on the partition, and then sent back. That calling party is sent en bloc. All digits are sent at once. So urgent priority is actually necessary not to invoke any sort of interdigit timeout. If we were sending them overlap, then we could not send urgent priority, because as soon as the calling party was +1 and then any other character, it would match, and that wouldn't work. But en bloc, urgent priority will work. We're going to take a look even more in depth at that today, because there's going to be a place within globalization, the outbound globalized routing, which we haven't looked at just yet, that it's going to be absolutely necessary to have urgent priority, and without it, we will incur interdigit timeout for all calls, even 911 or 112. Take a look at that. Okay, and then all we do is drop pre-dot, so we drop the plus and the 1. Config for the Austin phone here is \++.1 bang, so it looks like this for the Seattle phone, but the dot is moved over to the left one place. This allows us to identify +1 calls, so from the US, but not from our area code. And yes, this would be a longer match. We would probably have put in a longer match in this code. I just didn't have a lot of room to write it. This would work, but there could be other issues. Take a look at all those. And then for the Amsterdam phone, the calling party transformation pattern is \++.bang. We drop the plus with a pre-dot, and then we prefix 00. So we looked at this slide yesterday, and if you've ever read any Cisco textbooks or documentation regarding call manager fundamentals or anything, you saw the slide from yesterday, which looked like this. But can anyone spot something new on this slide today? There's a new external configuration order. A new entity here. Everything's been shifted down to allow something new at the top. Can spot it? Translation pattern at the top. That's exactly right. Previously, route patterns matched all of our external calls. And I want to pause for a minute and let that sit in or sink in after I make this statement. So prior to 7.0, and it's not that you have to do things this way in 7.0, but for globalization, you do. Prior to 7.0, route patterns matched everything that we had in terms of normal numbers that we would dial. I mean, sometimes translation patterns matched, and then they would, via their calling search spaces, reroute those calls back into the digit analysis engine and could look at other translation patterns or DNs or route patterns. We use them occasionally, but for the majority of our call routing, I should say the majority of our external call routing, so from IP phones to the outside PSTN world, we used route patterns to match and send those on to route lists. Now we're going to use something new called translation patterns. We've had these forever, but we're now going to use these as our primary PSTN route patterns, or our primary PSTN patterns. Okay? So, just like in the design or fashion world or whatever, pink is the new black or something like that. Well, translation patterns are the new route pattern. Just remember that. Translation patterns are the new route pattern. So we'll take a look at why they're going to be the new route pattern right now. So first of all, the translation pattern matches the dialed digits for external calls now. Didn't in the past, but they do now. The route pattern matches the globalized number from the translation pattern. Okay, so the translation pattern is going to globalize the number on the ingress from the IP phone, and I've got another slide that's going to show this in even more detail next, the route pattern matches the globalized number from the translation pattern, and it points to a route list for routing. Everything else happens like it did. The route list points to a prioritized set of route groups, or maybe just one route group. The route groups point to the actual devices, possibly one in our CUCM lab our CCIE lab environment. Each route group will only contain one gateway or trunk. Well, typically, there might be occasions where we'll have multiple. Not in this module, but there might be, there definitely will be at some times. Probably when we get to Cube, we'll actually take a look at a very good reason why we might have multiple trunks inside of a route group. And then they have their distribution algorithm, so either top-down or circular. And then we've actually got the devices themselves, the gateways and trunks, right? So we also looked at yesterday where we could apply digit manipulation. Does anyone remember from yesterday, or if you're watching this module, maybe you happen to watch the module 9 on advanced dial plan, line device approach, hours ago, but does anyone remember where we were able to do digit manipulation yesterday, and what was special, or something special in terms of consideration to take into account when it came to digit manipulation? I'll open that up. Somebody answer this question. Humor me.
You can do digit manipulation at every step of the line. It's just every step you get closer to the egress overwrites the previous one.
Excellent summation. That was true until this. That was true from yesterday. Absolutely correct. Let's take a look here. So first of all, the configuration order is still from the bottom up. Call routes from the top down, but the configuration's from the bottom up. We have the ability to perform digit manipulation here at the translation pattern. Okay? And this is actually what we'll use to globalize. Arrow. We have the ability to perform digit manipulation optionally at the route point. We have the ability to perform digit manipulation at the route list route group combination called the route list details, and the ability to perform digit manipulation at the devices, where yesterday we said this was preferred. We talked yesterday about how the device level, and this is new to 7, so calling and call-led party transformation patterns were something that were new, added via CSS and partitions to the gateway level. We mentioned how, and this is still true from yesterday, if digit manipulation was performed at the route list level and the gateway level, that the gateway furthest on down the line would trump the route list. Okay? The reason I wrote trump on the route list is the route list has just been trumped. He's been usurped. Also, any digit manipulation performed at the route list, at the route pattern would be trumped by the route list. Okay, so any digit manipulation at the route pattern is trumped and overridden by the route list details, and then anything at either of those steps is trumped or overridden at the gateway. Okay, by calling and called party transformations. However, there is no trump from the translation pattern. Anything that we do at the translation pattern takes place immediately. Translation patterns do not fall into this 3-tiered tentative transformation. Okay, so that's what I call the route pattern, route list details, and device gateway is the 3-tiered tentative digit manipulation. If it occurs at step 1, it could be overridden by step 2, route list details, or step 3, devices. However, translation pattern is not subject to that usurping or that trumping. Anything done at the translation pattern takes place immediately. Go ahead, Michael, you have a comment?
So is that specifically as it relates to globalization, or is it for all DM?
That's a great question. Translation patterns. Now, we mentioned yesterday and showed yesterday, translation patterns have calling and call-led party transformation. We've always used transformation. So if I have a calling or call-led party transformation configured on a translation pattern, it happens immediately regardless of usage. Doesn't matter what we're using it for. Yesterday, we configured a blank pattern in a translation pattern and then translated the call-led or transformed the call-led to a PSTN number, 9, to match the access codes on the route patterns. 9, and then I think it was 206, 501, 5111, which was line 1 on our PSTN phone. And we remember that it then looks at its calling search space to find a match to that transform number. But the transform number took effect immediately. Even if I'm just transforming numbers on a translation pattern back and forth between internal DNs, whatever it is I'm using it for, translation patterns take effect immediately. Route patterns are tentative based on the route list details. And then route list details digit manipulation is tentative based or pending the investigation. Is there a match at the gateway calling search space for either call-led and or calling transformation patterns and partitions? I realize that is a mouthful to say. Surprised I kept it straight. It's certainly an earful to hear. You might need to go back a couple times on the recording to fully get that down, but it's very important that you understand that. The reason that this is going to work for us, and the reason that we now use translation patterns, is that we can now globalize, perform call-led party, and optionally calling party digit manipulation on the translation pattern. It will take place immediately, and now at the ingress of our call, IP phone goes off hook and dials into CUCM. CUCM matches digits. If we match them at the translation pattern, which is now desirable, then we can transform them immediately into a E164 fully proper globalized format. The power of this, the reason that we're doing this, you'll see in today's task when we have fallback route groups. It doesn't matter if our route group primarily goes, our route list calls a route group that primarily goes to, let's say, standard local route group and goes out the local gateway, or whether it goes out another country. We don't have to change any of the egress call-led party digit manipulation on the device level from the standard format that we're going to show you. We don't have to change it for every single call to work. As long as those calls, the call-led party was globalized, every call will work with a few simple set of egress call-led party transformation pattern in a partition in a CSS. The CSS is used by the gateway. So we're first going to globalize on the ingress at the translation pattern, and then we're going to localize, that is, we're going to perform digit manipulation again on the call-led number at the egress, which will be the device, the trunk or the gateway, based on call-led party transformation CSS and pattern matching. Yeah, Michael, you had a question? Go ahead. He was asking or commenting, but now if calling party transform or call-led party transform, does that still apply? Okay, so first of all, translation pattern, whatever we transform. We talked yesterday that calling and call-led were treated independently of one another. So we talked that they were treated independently because of this whole, route pattern was tentative, then route list details was tentative. So in other words, I could transform calling party at the route pattern level, and then transform call-led party at the device level, and those two wouldn't cause any problems. They were independent of one another. In terms of translation patterns, since it does everything immediately, it doesn't matter, I don't want to say it doesn't matter, but whether we transform calling or call-led or both, it happens immediately. And you'll see that there are times that we're going to want to transform both. But then we still have the ability to transform to localize. Once we've globalized at the translation, we still have the ability to transform or localize at the egress device. And in fact, we will have to localize our call-led numbers. Our calling will just be dependent on if we transform them the way we wanted them at the translation pattern or not. And if not, then we can do some additional transformation here. Okay, last slide. Outgoing PSTN call, call-led number, globalization, and then localization. We just showed an overview, top-down approach, how we're going to do this. Let's take a little bit more detailed look. So we've got a Seattle IP phone. And that phone goes to place a call. They dial 9-206-501-5111. Their calling search space is, of course, consulted to find a matching pattern within a partition which is within their calling search space. We find that in the form of, and I mentioned here again, kind of flash a couple times, globalization at the call ingress, but we match that in the form of translation patterns. I tried to keep the same colors from 2 slides ago, where I believed I used orange for globalization and kind of a bluish color for localization. So the translation pattern takes 9 or matches 9 and then 10 digits for the local call. In the partition PSTN US, partition US PSTN, which is in the CSS that the user had. The user's still doing line device approach. I just didn't have enough space to really write out the line and the device calling search spaces. So you'll just have to trust that what you remembered from yesterday in terms of line device, that's still in effect here at this phone. We discard the digit, and the digits that we're going to want to discard at all of the translation, I'll also refer to them as PSTN patterns that we'll be creating today in our tasks. The digits we're going to want to discard are any of the non-E164 proper formatted numbers. Okay? And we're going to prefix +1. So we're doing something similar to what the carrier, or what we were doing when we were ingressing or inbound calling from a carrier. Carrier is sending us 10 digits at one site, 10 digits at another site with a 0 prefix. We dropped the 0 and added +31. Here, the user is sending us 9 and then 10 digits. We drop the 9 because that's just locally relevant to our PBX, has nothing to do with E164. And we prefix the plus and our country code. And then translation patterns don't point to anything, do they? Route patterns point to route lists or gateways, but that's the only thing they can do. That's it. Translation patterns don't point anywhere. Instead, they have a calling search space, and that is used to try to find a match for the call-led number once it's been transformed. Right? So we transformed it to +1 209, +1 206 501 5111. Now we have to look in this calling search space for my translation pattern here to try to find a partition and a matching pattern that will at least match plus something. So next, we do have a calling search space which is called TP to RP PSTN, translation pattern to route pattern PSTN. And what do you know? We find a pattern that matches backslash plus anything in the partition of TP to RP PSTN, which is inside that CSS. This is the place here where if you do not have, this is what's known as our globalized route pattern. If you do not have on your globalized route pattern urgent priority, then it doesn't matter how specifically your calls were matched from the translation pattern, whether you had urgent priority or did not have it checked at the translation pattern level. If you do not have it checked at the route pattern level, where the DNIS digits are being sent en bloc all at once, from the IP phone into the translation they were being sent overlap, one digit at a time, whether it's a SIP phone with KPML or a skinny phone. SIP phones that are using dial rules wouldn't apply to that, but we're not talking about that yet. Okay, those were overlap. But from the translation pattern to the route pattern, that is en bloc. Because all the digits are being sent at once, this bang will not only match one digit place, but it will match everything because they're all delivered at the exact same time. It's that reason that we have to have urgent priority checked at this route pattern, or we will experience interdigit timeout for every single call. Okay? Beat that into your head well enough? Good. All right, so now our route pattern points to a route list. Route list contains, let's say, standard local route group. Standard local route group tells us to do what? Go back to the device pool for that calling party and look at their local route group, and then replace itself with the actual route group that was referenced in the calling party's device pool, and send the call on out to the proper gateway. And then that call, now that call needs to be localized at the egress, right? Because how is it formulated? It's formatted as +1 206.501.5111. Well, that's going to be fine if we have a SIP trunk to Skype or if we have a GSM carrier. But what if we just have an ISDN PRI? ISDN, well, at least most carriers, I can't really speak for all, ISDN will carry the plus, by the way. But most carriers won't, at least in the US, accept those plus numbers. A number of carriers in the EU are beginning to accept plus for call-led party. And that's going to be nice when we can send it to everyone. But let's say we cannot send it to our carrier for whatever reason. This is where we need to perform localization at the egress. Okay? So now the gateways, calling search space. Remember, we could have done digit manipulation here, but did not. We could have done digit manipulation here at the route list details, route group area, but did not. But now at the gateway, call-led party transformation CSS, we'll look up that party's CSS, and here we find a CSS for call-led party transformation pattern corporate headquarter gateway, and we'll use that to route that to a call-led party transformation pattern, which is in a partition visible by the CSS that happens to match. And here we've got a very specific one, backslash plus 1.206 bang. We're matching based on a longer match with the 206, but we're only doing discard digit. That's the DD, not dial digits. Here, I mean discard digit. Sorry if that's confusing. Discard digit equals pre-dot. So I'm dropping the +1, and I'm prefixing, I actually say prefixing a 9 here. That was a mistype. I would definitely not be prefixing a 9 here, unless the carrier wanted to see it. Okay? I apologize for the mistype of a prefix 9. I simply want to discard and drop the pre-dot. Simply want to drop the pre-dot. I'll fix that as I fixed the trace files in the slides from yesterday's. It won't fall into the recording, but whenever you just look at the slides, which are part of the course curriculum for anyone viewing the recorded content, if you just look at the slides, yesterday's slide, or module 9, I had already gone back and fixed, and I'll fix this here as well as my presentation, where you guys get those in the recorded format. So then once the call-led party transformation pattern has occurred, there's really no calling search space. It doesn't look to send it back anywhere. This really just kind of, think of this CSS sending it out, and then think of it as kind of like a loop back. It loops the call out to the call-led party transformation, does the transformation, and then it sends it right back to the gateway. Kind of all happens right there on the gateway. And then the call goes out to the PSTN. Okay, so let's take a look at the Amsterdam phone dialing 001, so 0 for the PSTN, 0 for long distance, 10 704 7444. They look to their CSS. The CSS finds a partition. CSS Netherlands PSTN finds partition Netherlands PSTN and a matching translation pattern of 00 and then next digit 1 through 8. And then this would have been, let's see, 8 more digits, looks like, for a total of 9 plus the 010 plus the PSTN 011. Yes. So then we discard digit pre-dot. Now, 0 was the PSTN code. We can understand why we would put the dot after the first 0 and drop that, just like we dropped the 9. Why are we dropping the second 0? Anyone have an idea why we're dropping the second 0 here? Remember that earlier I said that the next 0 can, a number of times people refer to it as part of their area code, but it's not part of the proper E164 format for numbers. The preceding 0 is actually a national or long distance trunk code. I also mentioned yesterday, and I'll reiterate this today, for those taking the CCIE Voice Lab and thinking, holy crap, do I have to remember every single numbering plan and all their specifics for the world, for all the countries? You do not. Don't worry about that, okay? If I wanted you and needed you to drop that preceding 0, I would be, as a proctor or a lab writer, very specific in writing down what the format for this particular lab that you were going to work on was. You would not be responsible for inherently knowing what should be sent to the PSTN and what shouldn't be, as I've done in the lab task that we're going to look at in just a moment. Okay, so 00, neither of those fall into the proper E164 format. So we put the dot just to the right of those two zeros and drop it. We know that the next 2, or potentially 3, but in this case next 2 digits are an area code, and so, or geographic code. So we know that we actually need to have yet to be prefixed to the beginning. If we already have the geographic code, what comes next at a macro level? The country code. That's correct. So we have to add the country code and then a prefix indicating, a prefix of a plus indicating that what is following that plus is a country code. So we prefix +31. Then we look to our CSS, TP to RP PSTN, same one as was here. So why? Find that exact same route pattern. We're routing everything to that route pattern. A little bit too much animation all happen at once. But then the call routes out to the route list. Standard local route group goes back to the device pool, finds the calling party's local route group, replaces itself with that route group, and then sends the call out to the gateway. Now we have +31, +31 10 704 7444. But the carrier, at least in this case, doesn't route plus. Or country code, for that matter, for something that is just a local number. Remember before, our country code is also our long distance, US, I'm sorry, in North America. Our country code is also our long distance access code. Remember I said that was going to be really, really handy and kind of a nicety? Well, that's not the way it is for every country. In fact, I don't know of any other country, 31 is not the Netherlands long distance code. 0 is. 44 is not the UK's long distance code. 0 is, right? So we need to drop the plus, but we also need to drop the 3.1. And we're going to then route that call as long distance. So that means the PSTN needs to know about the 0. So if it needs to know about the 0, why didn't we just, Mark, why didn't we just drop the 10, the PSTN access code originally, prefix a plus, and send it on so that by the time it got to the gateway, all we'd have to do was strip a plus? Or why did we even do any of this? Why didn't we just strip the 0 and send it directly onto the gateway? You might be asking yourself that question. You have to keep in mind what I said, which is that it may not seem intuitive. As Michael pointed out, it's very counterintuitive to begin with. But I promise you, once we take a look at backup route groups, call forward on unregister, SRST, AAR, everything is going to be so simple that it will be crystal clear why we're actually going to all this work to globalize a number only to send it right back to the localized format that it was originally in. Okay? So then that call is going to route out the Amsterdam gateway, but before it does that, we need to localize it. So we look at the calling search space for the call-led party transformation. It's branch 2 gateway, or CSS, CD, PDP, branch 2 gateway. Inside, send that call to a partition of the same name. I like to name them the same thing, just with the difference being the preliminary, or prefixed, or you can have it as a suffix, CSS or PT, whatever the entity is, device pool or route group. I like to either prefix or suffix that. I tend to actually like to suffix it, but I've been prefixing it lately for whatever reason. I like to do that so I remember what kind of entity it is, and so I don't get confused. Like if I see just the name CD PTP branch 2 gateway, and then CD PTP, which stands for call-led party transformation pattern branch 2 gateway. If I just see those two of the same exact things, I might think, well, wait a minute, which is which? Which one is a CSS and which one is a partition? But anyhow, I also like to name the CSS and partition very similar to one another so that it's very easy for me to go back to the CSS and check the partitions and make sure that I have the proper ones in there. So anyway, we have to match the call-led number, which we could just match plus, but then we wouldn't know what to strip. We need to match at least as much as we need to strip, and sometimes more if we want to have a longer match. So here we're matching plus 3.1 dot bang, stripping pre-dot, and although this was an error saying prefix 9, we do want to prefix a 0 here. The prefix of the 0 is the long distance access code or national access code. Why didn't we leave that in again? Because it's not part of the proper E164 number, and if we would have rerouted that to Seattle, we wouldn't have known what to do with that 0, or we'd have to have another call-led party just to treat that one specific instance. So that was a loop, so it looped out here and back, and then the call goes out to the gateway in the proper format.
Hey guys, okay Mark, so with this in a nutshell, the on my phone I received a call and it's got a plus number on it in my missed calls, and I hit redial on that. That number is going to skip that translation pattern and go straight to the route pattern, is going to pick that up and then route it out because it starts with a plus.
I'll turn your question back to you with another question. I'll give you a partial answer and then a question. The partial answer is yes, that would be a supported format of making this all work. We're actually going to look at an alternative one, maybe a bit better one. But if we did want to do that, we did want the missed calls to go straight, bypass the translation and go straight to the route patterns. What would we need to do to accomplish that? What would the phone need to be able to see to accomplish that?
The partition.
That's
of
correct.
the route
The
pattern.
phone's calling space here or here would have to have the partition of the route pattern in addition to the partition of the translation pattern. That's exactly correct. Do you see any caveats with doing that? Any things that would be missed or
Yeah, like if it's,
overlooked?
let's see.
Spent a good deal yesterday looking at
Yeah.
class of restriction or class of service.
Yeah, I see what you mean on
If
that.
all I did, if all I did was give this partition to the calling search space of the phone,
Yeah.
then while I couldn't pick up the phone and dial because I don't have plus on my keypad, none of the
Can redial.
IP phones except for the dual mode phones have those plus yet, but they are actually going to begin supporting them. There are soft clients that do have them, such as CUPC, so Unified Personal Communicator. There's certainly applications that do. But while I couldn't today dial from the keypad of the phone with a plus and therefore usurp and do away with all class of restriction, kind of bypass that, anyone that called me from internationally or nationally, if I was only allowed to dial local, let's say, I would be able to return the call back to anywhere. So I could simply, from my cell phone, call up, call you up in South Africa and say, hey, give me a call real quick, and then I'll call you right back.
Yeah,
And,
okay.
it would cost me the toll for the first minute to call, and then you would call me, and it would cost you a minute to call, and then I'd bill the rest of the hour that we were going to talk, I'd bill that to the company just with the missed calls. So it would work to do this to the route pattern.
Yeah.
And in the CCNP Voice Lab, if you weren't told to enforce or continue enforcing class of restriction for missed calls, then it would be a fine option and a lot less configuration to simply add this partition for the route pattern to the CSS. The way that we're going to do it today is to retain enforcement of that class of restriction, which means that we will create duplicate route patterns, duplicate PSTN patterns, which will be translation patterns with the plus symbol. And you'll see at that point that there will be very little that we'll need to do in terms of transformation. And the only reason that we'll do them is to enforce the class of restriction. We could create multiple copies of the route pattern with the plus, or with the backslash plus, but you'll see another reason why we will possibly want to do make them as translation patterns. And actually, before I move on, let's just go ahead and, since we have this visual here, let's just go ahead and hash out one last thing. Here we've been talking about outgoing PSTN calls and globalizing the call lead party number. When we were talking about inbound calls, we were largely concerned with globalizing the calling number. Now, whether we want to globalize or we just want to leave in some other format other than just our 4-digit extension on our phone, whether we want to globalize or just leave in that format, our calling number on an outbound call lead path and number, we still may want to change the calling number to something, whether we globalize it, whether we just make it into whatever it is we want the PSTN to see. Remember that yesterday we began taking a look in Module 9 at considering doing digit manipulation. So here we have digit manipulation for call lead. But yesterday we took a look at beginning to do digit manipulation for calling at the egress gateway. And does anyone remember what the big caveat that we ran into, the big stumbling block that we ran into by using calling party transformation patterns at the egress gateway was? We were able to match the calling pattern, but remember at the route pattern, if we performed calling party transformation, it happened immediately based on the call lead number, right? It happened based on the call lead number. What do I mean by that? somebody dialed 911. That was the call-ed number. And we transformed the calling based on the person who dialed and the type of number, the type of call-ed number that they dialed. So we were manipulating calling number based on both who was calling and what they dialed. If we did it at the route list details, we were able to do the same thing because the route pattern handed it directly here. We had already matched that call-ed at the route pattern. It's handed directly and only to a route list. But if we did it at the gateway, we had to use a CSS, which went out to a calling party transformation pattern. And were we able to manipulate the calling number based on who was calling? Yes, sure, no problem. Were we able to manipulate it based on who was calling and based on the digits that they dialed? No, because we had to rematch a pattern, and the pattern wasn't the call-ed, it was the calling party that we were matching. So we were matching, let's say, 1XXX. Well, that would transform every type of call, every type of call-ed pattern that 1XXX or 1001 had placed. It would transform their calling number to the exact same format regardless of the call-ed dialed digits. That was undesirable. So that's where we went back and did calling at route pattern, because we were translating or transforming calling based on call-ed, based on dialed digits. Okay, so that was all fine and good, but now we only have one route pattern, one. So now it's no longer based on dialed digits, it's based on a globalized format. This is another reason why we might want to do calling party digit manipulation at the translation pattern. So we'll do call-led party digit manipulation here, and that's going to be to globalize the number to get it to the route pattern. But we'll also most likely do calling digit manipulation here. That way we can manipulate calling party numbers based on the actual calling party and based on the digits dialed. And it's for that reason that we may want to have duplicate translation patterns as \+ to route missed calls, to do one button dial of missed calls, versus having, well, actually we could still do that with route patterns, but we would just have to, the problem with doing it with route patterns is then all of a sudden our concept and our theory gets kind of mushy, because you're like, well, wait a minute, which do I create translation and which do I create route patterns for? If you just keep it simple and remember that translation is the new PSTN pattern, or translation is the new route pattern, then all of your digits that are dialed, either by an application, like a web application, like Web Dialer, or speed dials, or missed calls, or even just a keypad, everything routes to a translation pattern. It keeps things a lot simpler. David, go ahead.
Hey, on a side note, the providers in the stateside with PRIs, traditional TM PRIs, do they allow for plus number being included in the calling number?
That's kind of a hard to answer trick question. There are some carriers that will absolutely, in fact, I would say maybe most carriers in the larger markets, in the larger cities, that will not allow anything to be in the calling number except what is part of your DID range, your direct inward dial range that they've assigned you. There are many carriers like that, if not most. However, there are some carriers that will let you put whatever you want in there. So it's not that the ISDN protocol won't accept it and that the SS7 signaling protocol won't carry it. They will. The problem is more just in terms of how their carrier switch is configured to reject calls with what they would consider spoofed ANI. So something that doesn't actually belong to you. You know, because then I could say that my call was coming from your boss. You know, your boss is mobile number, I could spoof that as my ANI, and you'd pick up the phone, but really it's somebody else, you know, or a collection person, or anyone could spoof anyone's number. Some carriers will actually allow that, although they shouldn't. They do. I've spoofed the ANI of the White House before on certain carriers that just allowed it, just to, kind of show people, because I'm a geek, I guess, that I could do it. I don't know. Anyway, but most carriers won't allow it. So they would most carriers would deny the call if you had an improper ANI. Michael, go ahead.
One of the things you got to keep in mind where you actually have to spoof the ANI is for things like mobility or mobile connect, where you want to try to send the original calling party's info out. So if somebody calls via cell phone into my desk and I want to see the original calling party, not my desk number, I obviously have to provide a ANI other than what's on my trunk.
That's a good point. And then there's also the very likely possibility that you're working with some form of Cisco emergency responder or emergency, whether it's enhanced 911 in the States or some form of enhanced 112 or emergency location information and DID that routes or maps to location information. What in the States is known as ELIN, your emergency location identification number, and your ERL, your emergency response location. Those are also many times spoofed from, maybe, I don't want to say spoofed, but have to be masked from trunks that don't actually carry or don't actually own those DIDs in order for everything to work. So in terms of can you send the plus, or even in terms of can you send ANI that doesn't belong to you. First off, I'll say this. In the CCIE Voice Lab, you can send anything. It's just a router that's the PSTN backbone, right? In our lab, you can. In the actual lab, if they tell you to send something, then their carrier, quote unquote, which is a 2811 router, it supports it. In the real world, your mileage may vary, so talk with your carriers. Stateside, it just depends on if you can, if your carrier cares or not. If they don't actually deny your calls, then you can do it. Some of them will not deny your calls, but they'll just rewrite your ANI to whatever they want it to be, maybe your primary billing number or something. And then others will deny your call altogether, but you can a lot of times, depending on how much buying power you have with them, if you have 500 PRIs across the US, then you can probably negotiate that they let you send whatever you want, or else you'll take your business elsewhere. So just like everything else, it depends on kind of how much influence you have. All good questions. Anything else before we move on? And Christopher, to your comment that US carriers are always behind the times, I couldn't agree more. In Europe, I can get 25 to 30 megs synchronous up and download with ridiculously low latency for internet, not to mention calling. E1 supports more channels. But then if I go to places like Japan, I could get easily 70, 80, or 100 meg synchronous up and down. Yeah, our carriers are fat, dumb, and happy. They're collecting profits on equipment that hasn't been upgraded in a while, and they're quite happy to do that. I shouldn't say that, because I know a number of my students work for the carriers, and I don't want to offend anyone, but I also realize the business side of it as well. I do understand that. But all that being said, if anyone's listening, I want more internet bandwidth at my house, okay? By the way, Michael just pointed out that it's possible, or asked the question and kind of posed the question/comment, is it possible, or maybe it is possible, that the lab would potentially ask for things that would require a mix of route patterns and translation patterns. So let me be clear. When I'm talking about the new way to do things, I'm not necessarily saying that. I am saying for proper design moving forward in your enterprise or in your consulting arrangements, that you should create translation patterns as the new PSTN patterns. However, the CCIE Voice Lab has never been about standard. It's been about what can we ask the student to do without directly telling them what to configure? What can we kind of basically tell them what it is we're expecting to see without telling them how to configure it? In fact, let me reiterate it in another way. I have often taught my students to look at the CCIE Voice Lab, or any CCIE lab for that matter, as you are a consultant and you're going into a client, and the client happens to be extremely knowledgeable. They could do the work themselves, but they're lazy. They're just not going to do it. And they know exactly to the absolute end of the spectrum what is possible in terms of configuration that you could get at, or I should say not configuration, but in terms of, I don't want to say a workable solution, I'm thinking of a good word. In terms of, that's the word I'm looking for, functionality, in terms of what functionality could they get out of their system. They know exactly what it can perform and provide. However, they're too lazy to do it, and so they're asking you to do it. But just like any customer that you might consult with, they are going to act, or I don't want to say your customers are acting, but they're not going to necessarily be able to enunciate it to you very well and tell you exactly what they want done and how they want it done. They're just going to tell you the functionality that they want out of the system, and as I mentioned, they happen to know that the system is able to provide it. So that being the case, they're going to give you some crazy requirements. Most of it will be straightforward. Most of the CCIE labs in general will be straightforward. They'll ask you to perform a number of tasks without telling you what to do, just telling you the functionality they want. And they'll ask you to produce troubleshooting results, whether directly fix something that's already broken inherently in the startup configs, or troubleshoot something as if it were broken, copy the debug or trace output down on Notepad, save it to the desktop, and write a brief comment at the bottom or top of that Notepad to let the proctors see, grade, and know that you know what it is actually going on or occurring there in the tracer debug. Most of it's going to be fairly straightforward. But there are going to be things that they're going to ask you to do that will just completely seem impossible. You have to think outside the box. You have to think with all of the tools that you have in your toolbox, and you have to come up with a way of it. So there will be times when you'll have a mix in the lab of translation patterns and route patterns performing different things. There's also going to be reasons, even in this lab that we're going to do today, why we might have multiple route patterns. For instance, if I want most calls to go, coming from either direction, to a route list with only standard local route group, but then some calls I want to go to a route list with a backup gateway or backup route group as well. Then I'll need to have another route pattern. It'll match the exact same thing, /+, but it will be another route pattern, maybe a little bit more specific, because it will point to a new route list. Or maybe it could be equally as specific, which then it simply could not be in the same partition, so we'll put it in a different partition and give the translation pattern a different CSS. More likely than not, we'll use more specific duplicate route patterns to route to different route lists. But there will be reasons why you might want to have a mixture of both.